You don't have to specify all the instances and the images or videos, but you can just provide one prompt, whether it's text or just like a visual example with one box, and the model would be able to segment all the objects in the scene.
There was a nice big conference expo with like multiple people, and then the prompt was people sitting. And the model was able to exactly localize and identify among hundreds of people, only those 3 people who were sitting.
We took 100 datasets from Roboflow universe that were diverse in terms of what domain they touch, and that's coming from real users having real problems. And yeah, Segmentation3 performed state of the art on that dataset.
I typed in person wearing a leather jacket and I hit find objects and then gonna do save and it got it. Hello, today we are talking about Segment Anything 3, or affectionately called SAM3, a new model that was just released by Meta yesterday. And today we have a couple people from the team who helped create this model joining us, along with some RoboFlowers, to dive into the capabilities and understand some of the inner workings and the things that are happening under the hood. To get started, Haitham, would you like to introduce yourself?
Hi, everyone. My name is Haitham. I'm a researcher at Meta. I've been working on projects like SAM2 and SAM3, and I'm happy to be here to answer any questions about SAM3.
Hi, everyone. I'm Kalyan, also a research engineer here at Meta, working again in the computer vision space for the last few years. Really excited to share what we have been up to again on the SAM team for the last few years, working on all sorts of different multimodal problems. Yeah, thank you.
Hello, my name is Peter. I'm doing open source work at Roboflow. Been using SAM2, SAM3. So I'm very excited to be here and have an opportunity to ask some questions.
Beautiful. All right. Now, with that said, Peter, I think that you have a few questions lined up for the team, so I'll pass things over to you.
Yeah, okay. So I think that we should start with just a very basic question because the model was released pretty much yesterday. So what is SAM3? Like, how is it different than original Segment Anything and SAM2 that was released last year?
So first of all, like Segment Anything model, there are a family of models for universal segmentation and images and videos. SAM1 and 2 supported geometric inputs like clicks or boxes for instance segmentation. And this is extended now for text prompts and visual exemplars, as shown here in some of the videos. So SAM3 is just is a unified model for detection, segmentation, and tracking, and it extends upon the SAM1 and 2 model capabilities, supporting text and visual exemplar prompts. This is like a significant advancement because being able to prompt the model with text is more amenable to automation. So you can imagine the set of use cases that this opens to the public.
Yeah. I mean, you could automate stuff with SAM previously as well. People were comboing that with detectors or text-based detectors as well. I myself built a lot of demos with like Florence 2 plus SAM. People were doing like grounded SAM, which is pretty much grounding Dino plus SAM. So there was a capability already, but it was very iffy when it comes to like the range of text that you can use, yeah, and also like the speed of pipeline combined of 2 models is always higher than having everything in once. So that was that's so awesome to see that we can use text. But also, I think that another important thing is that previously, even when you prompted with boxes, because you could do that for SAM and SAM2, when you prompted with box or the point, you got only that specific object. So you got mask for that specific object. Another difference, I think, right now is that we can prompt with boxes, but get all the objects.
Right. So this is basically a visual exemplar. So I think it helps a lot with like basically, as you mentioned, you don't have to specify all the instances and the images or videos, but you can just provide one prompt, whether it's text or just like a visual example with one box, and the model would be able to segment all the objects in the scene.
Great. I have maybe a more technical question. All of those capabilities, so prompting images with text and visual prompts, and prompting videos with the same range of prompts, is it all executed with like just one model, just an overall API on top of that model? Like you use, the different codes to wrap it up, but is it the same weights all around?
It's a single model that's single weights as well. So it's just one model.
Okay. So now maybe let's dive a little bit more towards that text prompting of objects. So I guess it's not like totally open prompt. There are some rules on what prompts you can use. So can any of you comment on like what's possible, and also very interesting for me, why did we limit the range of prompts?
So what's possible is basically how we define it as a simple text. So a few words describing an object. It's not free-form text, so you can't like write open-ended questions or very long sentences. And one reason for this limitation is it allowed us to like be in control of what type of data we collect. So that was one like I think major thing for this decision, is that we really wanted this to work well, and in order to do that, we need like some more control on the data that we collect, and that's I guess one you can see it as a limitation, but I think that it just works. Basically, it works well.
Okay, so that was a trade-off between, hey, we would support a broad range of text prompts, but be mediocre, versus having a narrow it down, but really nail it down.
Exactly.
Okay, can we talk a little bit more about like specifics of those prompts? Like, can you throw in some examples of things that are allowed and things that are, you shouldn't expect them to work?
Yeah. So for these videos, for example, on the like top left, the dog example, you can prompt with something like a brown golden retriever, brown dog, a white dog, like some simple attribute related to.
I also have a question. Will it work with hex colors? So if I will say not white dog, but I will say #000 dog, will it work or not? I got that question on the stream like 30 minutes ago, and I was like, I don't know. I will ask.
No, I don't expect it to work on such prompts.
Okay, so colors work, sizes work. How about like referring objects across, like between each other? So saying something next to something or something in front of something.
I think we didn't specifically target for this, so I would say it's a hit or miss. Like the model was not explicitly designed to handle such like relations between objects. So yeah.
I'm asking because before we started, we had kind of like a short conversation, and Patrick used a prompt using word, I believe, wearing, and I was like, I'm not sure if that would work, and it worked. So that was an accident.
So this is where I was going to add another capability. It's actions. Like it could be an object or a person or something doing something. Like for instance, like I think it's from you guys. Like I saw on LinkedIn your examples. Like there was a nice big conference expo with like multiple people, and then the prompt was people sitting. So, and the model was able to exactly localize and identify among like, hundreds of people, only those 3 people who are sitting. So that's an example. Like it's also doing more than just attributes. It could be actions, associated verbs, things like that. So I don't know what bucket you would classify that into, but I would say simple referring expressions is one way of saying like it could work still. Although we don't explicitly collect data with that in mind. So
Yeah. Do you want me to I can show off a little bit about for the audience's reference, I'll show off what we were talking about a little bit ago.
Yeah, let's do it. Let's do
yeah.
it. Yeah.
So I have this collection of images here in my dataset in Roboflow, and I think that we were looking at this image of some people at a party, and they're about to have some pizza. And over here we have this find objects with AI, and this is a tool that is powered by SAM3. And in it, what I tried out was I typed in person wearing a leather jacket, and I hit find objects, and then gonna do save, and it got it. It found it, and I can even keep going, and I'll do like person wearing plaid, and we got that one. And then I can also do person wearing pink. Oh, yep, and that also got that one as well. So I have this person wearing a pink, person wearing a leather jacket, person wearing plaid. Yeah, and I
So
think
what-
Peter was like, is it supposed to do that? Is this what it
one way of
sounded to?
in my mind, one way of looking at this, the plaid and leather and pink are attributes of the objects here. So model is trained to work well with attributes already there. Our data pipelines were built intentionally with this in mind to collect specific targeted data within even the, like the whole taxonomy. Like we have a taxonomy within that. We also, of course, try to gather as much, variety of data with different attributes in mind.
So does that mean if I did like plaid person, that should also work?
You could try.
Oh, I found 0. I'm not sure in this situation. Interesting. All right. Peter, do you have
Okay.
any follow-up questions about that one?
We
I have some
still
other
learned a lot
images.
because I didn't know that I can use actions, so that's awesome. I have maybe let's talk about like it's on a similar topic. So what can we detect? It's a little bit a question about like the data set you trained on and how broad it was and what was included. I played a little bit with, because I always get a question, does it work with aerial images? And and for SAM and SAM2, the answer was mostly no. Yeah, people were retraining those models on custom data sets to include that capability. But with my tests of SAM3, it is pretty good at working with aerial images. So I would like maybe not only focus on aerial, but like, hey, how did you, create the data set? What is included? Have you thought about like some specific things that were not here before and now are included? That's pretty interesting to me as well.
Kalyan, you want to take this one or should I?
Yeah, sure. I had some 2 cents of mine on this. So basically, we were very intentional about our data pipelines. As our model got better with our initial data, we intentionally expanded and scaled our domains to a lot of categories. We in our paper we go in detail about this psycho-ontology and how we mine concepts. We try to explicitly handle a lot of this, like long tail distributions and fine grained concepts too, at a good level. So I could say in a way, explicitly or implicitly, we could have had this kind of aerial, like domains part of our, like active domain expansion for SAM3 specifically. And that in turn resulted. And also, of course, like model having seen a lot more data is also at some level able to, like generalize, having been grounded in language. At some level, it's able to do more things in a zero shot setting too, like as we'll talk more later on, like in all these Roboflow datasets or these ordinary datasets, which we never trained on these domains, or we also explicitly didn't, optimize for these categories, specifically, Roboflow already, right? Like it has a lot more diverse categories, which are, even the category names themselves are very unique, are very specific and very niche. So without even being optimized to them, since it's still picking on like, language cues and some visual exemplars, it's still able to do really well because it's still a very good foundational model, which has just seen a lot more data. Again, with the in the background, behind the model is also this very powerful data engine, which is, ensuring that we actively explore to more domains. I'll pass it on to Haitham. So.
Yeah, one more thing to add is we also targeted domains that we saw that the community cared about, like with the previous SAM releases, like the medical domains and area
Medical
imaging.
SAM was the big thing, the biggest fine tune probably.
Yeah, I think that's one of the biggest domains that the community cared about. So we also try to expand into in that domain as well.
We actually accidentally, I mean, maybe somebody got inspired, but they are asking about the medical images that were included in the data set that you trained on.
I think we mine from different data sources. I think there are some more detailed in the paper about like specific data sets, but in general, like we mine from various sources of data.
Okay.
Okay.
I also have another question that is also in the chat, and I wanted to ask about it. So going back slightly to prompting, is there any maximum amount of words, letters, tokens that are allowed within the prompt? Like how much can we put in that? I believe in paper there was something about limitation, but I let you comment on it.
So, I mean, any text that you provide will be encoded. I mean, the model was not trained for free-form text, basically. So it's hard to quantify like a specific length on the allowed text.
So just to add on that, I think the model itself, I think it's 32 tokens. The actual model itself, it's still, like clip style encoder, right? So the model's capability is limited at that. But again, as Haitham mentioned, the training itself, we explicitly try to contain ourselves to simple non-phrases so that we can focus more on the quality over, like capabilities. So.
Cool. Okay. So I also thought that it's limited to some amount of tokens, and that it comes from the fact that you are using perception encoder, and that's what it was trained on. I believe so. But we can talk about the architecture in just a second. But before we do that, because we are talking about the data, you mentioned Roboflow 100 VL, the dataset that you use to benchmark the model. So just for a little bit of context for people who did not heard about the dataset, we took 100 datasets from Roboflow universe that were kind of diverse in terms of like what domain they touch, and we said, okay, let's bundle them together and take a look how different vision language models can perform on those models on this data set. And that data set is like you guys said, pretty diverse, because first of all, it's coming from real users having real problems. So it's not a very clean set of images where everything is polished. And second of all, they are really coming from broad domains, from like medical to aerial to sports to documents. And Segmentation 3 performed state of the art on that data set. So yeah, I would like you guys to comment on like why is that an achievement, and why you guys wanted to benchmark on that specific data set.
I can take lead on it. So basically, again, like we know that domains like Roboflow are the actual real world applications beyond the academic benchmarks. So this is where most of the people outside the academia actually would try out these models. So I think it's very important for us because from both adoption point of view and to see how well or how helpful these models are for people outside beyond just, standard domains, like for instance, like medical's domains. It was something which was never thought when SAM1, SAM2 was conceived, right? But it's so cool that these are applied to those kind of domains. So I remember there are so many other domains, like as I said, aerial domains, satellite domains, where I remember a friend of mine who uses SAM for agriculture, land analysis in India. I was like, wow, this is really cool. So these applications are wild and highly impactful in my mind, so that's also very motivating for it. And Roboflow, in my mind, VL100 particularly captures a lot of these domains, which industry cares about, not just people in the AI community. So these real world applications are very encouraging and motivating in my mind. So
bringing it closer to real world and less research environments, pretty much. That's what.
Right, pretty much.
Yeah.
Day-to-day applications. Yeah.
I have one more question that is coming from a chat, but it's very interesting one, and I was curious: is that possible? Is there any way to prompt an image with another image, or it all needs to happen within a single image kind of environment?
Haitham.
Right now, it's more a single image prompting. So we try. I mean, we can try to prompt the model zero shot with different image, but the main application is mainly with the same image. It performs much better with the same image prompting.
Okay.
So if I might add on that,
sure.
So one hacky or one shortcut way you can do different interimage prompting is you could stitch those two images together.
So I had that demo like this for a SAM2 when we were kind of playing, okay, can it do re-ID? So what I did is I stitched two short clips from different angles. And I was like, okay, you see, it's still maintained those IDs across those different angles. So it's kind of prompting one with another in some way. Yeah.
Yes. But that being said, I think this is a capability that I also acknowledge that would be nice to have. And I think something, future project might explore. Who knows? So, yeah.
Speaking of capabilities that would be nice to have, how about re-identification? So I said, okay, that was a hacky way to do that. And a lot of people, when I started because I specifically got fascinated with tracking with text. So the fact that I can just prompt and I get I have 15 planes flying through the air and I get all of them and I kind of maintain the ID. But one thing that was happening with SAM2 and I believe is still happening with SAM3 is that if something leaves the frame and re-enters, there is a high chance that it will get new ID. Yeah.
Right. I think that's one of the main challenges. I mean, long inclusions or distractions from similar objects. It's a hard problem that we're also trying to solve. I mean, for SAM2, I think, and SAM3, it works. I would say it works well if there are not many distractors, very similar objects that are still in the scene. I think that makes it much more challenging.
Yeah. People were asking primarily about situation when something left the frame and then come back. I was specifically playing with basketball. So when you just pan the camera and, some players are left behind and they re-enter and whether or not they will get new ID. And I believe that re-identification is still something that you are working on. Yeah.
Sure. Yeah, it's especially hard in these scenarios for basketball, as I mentioned, because there are also many other players, sometimes similar looking players.
Yeah.
So it's more challenging for the model to re-ID the object. But say, for example, if it's just one object in the scene and then it left and came back, that's usually an easier case, and the success rate for the model is much higher.
Okay. So maybe another use case where it might be challenging. How about large resolution images? How does it work? Will SAM just resize the image to some predefined resolution?
Yes, we resize the input image to like 1K basically resolution, square resolution. So everything is resized down to that scale.
Okay. Okay. So people are asking, hi, if I would have a satellite image that is 20,000 by 20,000 pixels, how would it perform? Probably the idea would be to divide that image into smaller patches and run separately.
Exactly.
Right, exactly.
Okay.
And then you could also do some intelligent things on top of that. Like you could stitch them together. You could do like some sort of NMS suppression or overlapping filtering, things like that to get more, accurate results. So.
Yeah, and people are asking, okay, what will happen if the image is smaller than 1,000 pixels? It will get resized, so it will get larger. Yeah, but I assume that it would probably not necessarily. If anything, that would help. I think. Yeah, if anything, that will help. Cool. We started to talk a little bit about the architecture indirectly because those are the resize. Here's the limitation for the amount of tokens that you can have in the prompt. So we used models similar to Clip to process our images and prompts. So can any of you comment a little bit and tell us a little bit more about the architecture and how SAM actually works? SAM3 actually.
Sure. I think we have a slide about the architecture. Maybe it also helps to. Not this one. There's another one. Yeah. So basically, SAM3 is the modular model. So it consists of a detector and a tracker modules and a shared image and text encoders. So the shared the image and text encoders are based on the recently released meta perception encoder. It's based on a clip style of model, and the detector is a deter based model conditioned on text and on image exemplars. And the tracker inherits the SAM2 architecture, the transformer encoder decoder for tracking. So that's basically the high level of the architecture.
And it's not here on that visualization, but you can also prompt with boxes and points and how that is plugged into all that.
Right. So the tracker basically supports all the SAM2 capabilities, including points and boxes and masks as well. And so all the interactive capabilities for instance segmentation are still supported by the tracker, similar to SAM2.
Okay. So you pretty much take the embeddings for the image and you kind of condition it based on the somehow encoded visual prompts. Yeah.
Yes.
Okay. And maybe because I remember that's how it worked for SAM2, and I looked at the API of SAM3, and it's kind of bringing it back. When you run an inference with SAM2 on an image, there are like two stages. Yeah, you first pass an image and call, I believe, set image method, and then you have set text method. So can you talk about a little bit why you divided that into two methods and what are the upsides of that setup?
So I mean, this is more like on the engineering side of inference. So basically, we can have one image and different prompts. So you can set the image once. It basically runs the image encoder and caches the image embeddings. And then after that, you can prompt the model with different types of all the supported prompts like text, instance prompts like points, or visual prompts like boxes, all using the same cached embeddings.
And it works the same way for videos, yes? So if I pass you a video, you will create embeddings for every frame, and those are cached so that we save that amount of time and then can kind of like reset prompts and try different things, but it will be a way faster way to
Right. So, so you can do it in different ways. The way we do it for the demo is that we do like a streaming approach. So we don't compute all the embeddings before processing the video. We do it like on the fly, basically frame by frame, just to allow fast streaming. But in case like you're more interested in offline applications, say you want to do like annotation or so, you can, for sure, yeah, you can cache all the image embeddings and just run the tracking on top.
Okay. So speaking about the streaming application, I take a look at the API, and how it works right now is it wants you to provide all the frames up front, kind of. So, hey, split the video into frames, and then we will process that. Does it mean that I cannot use SAM3 with like a video stream that will come in the future, and I don't have all the frames up front?
You can. I think for the released API, it supports like a directory of images, or it can also accept like a video. So I think with minor modification, it also can accept a stream of
Okay.
like a stream. Yeah, I think this was
So it's
tried
not a
as well in
limitation of
SAM2.
the it's not a limitation of the model. Yeah, it's just like how you design the API around.
Right. Yeah. If I recall correctly, like the community actually tried this with SAM2. Like I've seen some.
Exactly. That is why
yeah.
I'm asking. Yeah, but I remember we had a stream about SAM2, and I was like, but it cannot support streams. And a few months later, somebody created a fork where they reorganized things and allowed for like a prompt for one frame and then stream the rest of the video. Yeah. So.
Right.
Yeah. Okay. That's pretty cool to know that it's still possible. Okay. So I got this question today on the other stream as well. How about model performance? So, like you also mentioned, SAM3 supports all the capabilities of SAM2. What did you guys improve between those two versions? Is it more accurate? Is it more robust? Like, is it faster? Can we talk a little bit about this?
So it's more accurate. Like we have results in the paper that compares SAM2 and SAM3 in terms of all the interactive instance segmentation tasks, like on images and videos, and it's in general like it improves over SAM2, and this is mainly thanks to like the different image encoder and also different pre-training data. So overall it's more accurate than SAM2. In terms of speed, I would say it's on par or a little bit slower. So the vision encoder is definitely like a lot larger than the SAM2 encoder. For SAM2, use a lightweight vision encoder, Hyra. But also I think with more advancement, like in the attention mechanisms and like the speed ups there, it's not much slower. So I would say it's on par or slightly slower than SAM2.
Okay. And you touched about this topic, and I would like to also maybe ask about why have you guys decided to switch from one encoder to another? Is it just because PE is another model that you developed, so that made sense, or?
Not really. The main reason I think is not having two backbones for one model. So this way you can just share the image features that are computed for both the detector and the tracker, instead of using SAM2 as a completely out of like a different model.
And also to add, I think like the language, like grounding, the P is already aligned very well to the language because it
was trained together. Yeah.
Exactly. So that also gives some, like implicit gains and performance.
Okay. Question that I didn't have on my list, but somebody asked it, and that sounds pretty interesting, about the memory bank and how it trades off, accuracy versus, speed and memory efficiency. Like what were the trade-offs that you guys need to face here, and what have you decided to do?
So for the memory bank, it's basically it still inherits like the SAM2 style of tracking and how it encodes the memory. There are many like so right now basically there is a single memory bank per object. So one limitation of this is that the speed basically decreases linearly with the number of objects, because you need to maintain all the memory banks for all these objects. So one like follow-up work would be to try to make this memory banks more efficient and shareable between objects. So that's something in general that would enhance the performance. Yeah.
Cool. Okay. Yeah. Patrick, I am running out of questions here, but maybe you have some.
Well, I did see there was one in chat that I thought was kind of interesting. I don't know if you can provide too much guidance on this, but their question was about fine-tuning SAM3 and getting it to, optimize for a specific domain. And there's one part of this question, this came from somebody named Damien, and they said, how much computation power is required? And then a second question is like, how large would the data set need to be for fine tuning? This was, I haven't done like a fine tuning job myself yet, but I was
did.
thinking about it.
I
We
did.
can
Maybe
we can share that. How about you can share your
sure.
experience as well, but maybe Haitham, Kalyan, do you have some kind of like
Sure.
guidance on this?
Kalyan, do you want to take this?
I can. Yeah, sure. I can take it. So I particularly like again like so I can talk in the context of VL100 and Node in the wild. These are again like 100 individual data sets, right? In VL100. So I've tried a lot on this, on fine tuning this, and I've seen like even with like very few images, like say like 10, 15 images, and of course, including all the prompts in the 10, 15 images, the model was already getting a huge boost in performance. Like I remember like Box AP would jump about like 20, 30 points in almost all the cases. So, and already as we report in the paper, like in few shot and fully fine-tuned setting, we get like the SOTA numbers blowing everything out of the park. This again comes from two factors. Like we have a very strong foundational model, and also the fact that it's already well aligned to the language. It's able to capture like all these, like prompts very well, like multiple ways of prompting while fine-tuning. And we already are speaking about technical components. We released full fine-tuning code in our repository. We already have some configs which directly fine-tune on Roboflow VL100 right out of the box, and also out in the wild. Feel free to try them out. And the way they are set up they currently run on about 2 GPU setting, where basically batch size 1 per GPU. And I had tried them out on A100s, and with, like some small changes in how I pack my non-phrases, I was even able to squeeze up to batch size 2 in some most Roboflow datasets. Some Roboflow datasets, it was not possible because of the huge number of categories in the classes. But for the most datasets, you can pack at least batch size 2 or more, and you should be able to do it in a couple of GPUs like A100. Again, like you don't need to do it for a very long time. You just need few samples of images, maybe like even in the order of like 50 to 100 is more than enough to get like good performance. By that time, the model most likely is already, like peaking at its performance. So
I have a follow-up question about that actually, and so I had this image here of a dashboard from a car, and I can do like indicator light. I've written this word so many times recently, I kind of forgot if that's the right way to spell it. And I think this is quite interesting. Hold on, save. I think this is amazing that it can already find all of these indicator lights. I did have an experience where I wanted to say do like the battery light or the ABS light or the kind of like check oil light, and I wasn't able to get it to find those, just like zero shot. I was thinking, oh, maybe this is an opportunity for fine tuning. Have you seen any specific like any specific use cases where you kind of thought, oh yeah, it really makes sense to do fine tuning, or oh yeah, that's a cool use case for fine tuning.
So, I mean, of course, like I'm not sure like how much data we have on this specific thing, but like from visually expecting, these are like clearly different, like visual objects, like in my mind. Like
Ah.
so the model already in my mind at a like a theoretical level should be able to identify this difference. So the fact that now it's not able to do it, I can see like, okay, these are not like, like far off. These are very clearly distinct things, but the model is not able to do it. So this will definitely benefit from fine tuning. And I've seen jumps in these cases where, like the objects are clearly distinct, but the model is unable to identify for some other obvious reasons, because this puts everything under one single bucket, right? So you could either do like prompting with like, like negative points or boxes in these cases, negative labels for boxes in these cases. If that doesn't work either, then fine tuning is the obvious next step to do this. And I've seen a lot of, again, VL100, I don't remember the data sets on top of my head. A lot of times, like, again, the model just tries to put them all in the same bucket. I think it was like this data set aerial pool, like where the different teams and coaches and all that stuff. So it was trying to put them all in the same bucket, but immediately after fine tuning, it was able to, distinguish them, because it was able to pick on like nuanced things like colors and like the hat difference in hats and things like that. So I think it's, settings like that.
Yeah, I had a different experiment where I was like trying to prompt the model for a specific car brand, and I was unable to say, okay, it's a Mercedes or whatever, and fine tune for like specific data set where each card was segmented and provided the brand for that, and that also unlocked that going from like general into like specific capability. So yeah, there's definitely a potential with not that many images
Exactly.
to do that. Yeah.
Again, to add, like the model is able to already like, localize and identify these objects. It's just unable to classify them well at this point. And once you fine tune, the classifier gets really better at doing these things. So
Was that also a conscious decision during the data collection, that instead of like going for specifics, you want to go for those like higher level phrases?
I think we also go into specific fine-grained categories. We talk about, like the super categories, the top level categories for which we do specific fine-grained data collections. I think we do that to a good extent, but also again, it is a single models. Of course, its vocabulary or capability might be limited, depending on how much you can pack into it. So it comes down to like, eventually like pulling out those capabilities from the model again through fine tuning. But yes, we do also explicitly, mine and annotate data for very fine grained categories. I don't remember all the fine grained categories on top of my head, but they're all in the paper. Yeah.
Cool.
All right. There is one other question I saw in the chat, which is this is actually just for the person who asked it, but I saw somebody asking about, can we prompt on a shipping container? And I do happen to have an image of a shipping container here. I'm going to try this yellow container and see. Actually, I haven't tried this image previously myself, so I'm not sure if this works.
Don't do it.
But don't do it live. This one looks pretty good, like yellow container, yellow
The
container,
bright ones,
yellow
yeah, the
container.
bright ones were. I'm not sure if that's orange or yellow.
Yeah, and that one maybe is a little bit weird, but I bet I could do the container itself as well. We can do this. And also not really sure. Did I just write container? I kind of wonder if shipping container would be a bit better. And that looks, I mean, that was a lot faster than me doing it myself. Nice. All right. I'm gonna maybe have one last question from my end, and it's pretty simple. Haitham, Kalyan, like, is there anything kind of specific that you guys would want to shout out today, or if people are interested in learning more about SAM3, like any specific places they should go to.
Yeah, I think, we released a checkpoint and the code for inference and fine tuning on GitHub. So I encourage everyone to check it out and stay tuned as well for any updates on the repo.
Can I have one more question? Because those checkpoints prompted me. Will there be other sizes than the one that is already released? For SAM2, there were multiple.
I don't know, I guess you have to stay tuned. I'm not sure.
Okay.
All right, cool. Kalyan, how about you? Anything specific that you think people should be checking out?
I think, yeah, the resources which Haitham pointed are already great place. I just also like shout out and acknowledge the team behind the project. It was a long time in making, and all the incredible people working on the project. It was great. And looking forward to all the cool things, community comes up with this, and yeah. So
Beautiful. All right, Peter, how about you? Do you have anything that you think people should go check out after this, besides maybe your YouTube video that you just published?
I mean, that was stream, but okay. Yeah, repo is one resource. We've also made collabs where we try to explain how those things work. So you should probably check it out if you have if you want to dive a little bit deeper. And yeah, there are things like Rapid and Roboflow that use SAM3, and I showed it on the stream few minutes ago, and people were blown away how it works. So you should try Rapid. Yeah, you can train models with some annotations and minutes.
I'm also going to ask Peter, is fine tuning service also up on Roboflow?
Yeah. I'm not sure if it's already on prod. Maybe Patrick knows more. But I played with that, on our testing instances, and that's where I used it. Yeah. So if it's not already there, it will probably be there shortly. So we will allow people to train with an UI. Yeah, we'll allow them to use their segmentation datasets to fine tune some.
Sorry, I'm just trying to speed run through it, but
speed run
yes.
to Patrick. So is it already there? Custom train.
Yeah, so I have this data set. This is like a car chassis coming down a manufacturing line. And this is one where the SAM3 was pretty good at finding a lot of it, but there was a little bit of touch up that I wanted to do. Yeah, and I think that if I come in here custom train, we have SAM3 in the Roboflow platform, which I think I saw a little earlier about computing power and infrastructure needs if you don't want to set up all the infrastructure yourself. This was actually going to be my shout out of you can come over to the Roboflow platform and try out fine-tuning.
I'm already going to start pointing people to this because a lot of my friends who are not from tech, for instance, I have a few PhD friends in life sciences. All their work is all about looking things through microscope and counting things. So basically what they're doing is just taking pictures and counting them manually. So I'm just going to tell them, just use this to fine tune your, data set. You should be able to count them directly now. So
yeah. It's very good at counting. I showed a demo today where I was like, hey, how many of that is in the image and how much time it would take you. And it's, very accurate. That's pretty cool.
All right. Well, to Haitham, Kalyan, Peter, everybody, thank you so much for spending your morning with us and answering a whole bunch of questions about Segment Anything 3. It's a super cool model. We've been playing around with it over here at Roboflow for the past weeks. And, I've been saying, we see computer vision advancements all the time, but I think there's been several instances where here, even us, we're like, wow, this is some kind of new magic. So I just want to say congratulations on all the work that you guys have been doing on this project. Please go find a way to celebrate a little bit after this.
Yeah.
All right.
I
and
can
with that, we'll-
also say that it is my favorite series of models by far. So highly impacted all I did for the past 2 years. So great work. Yeah. I can't wait for SAM4 already. So, see you next year.
All right. Yes, I see we have a lot of applause coming into the chat here. So we'll wrap it up for today. All right. Thank you to everybody who joined us today and brought your questions. Everybody, please enjoy the rest of your Thursday and go play around with SAM3 and find some computer vision challenges to solve. All right. Take it easy. Thank you.